Welcome back. I'm now looking at this idea of cell size. Cells are limited in the size they'll grow to, so they're small. Some, like our red blood cells in the previous video, that's helpful because they've got a job to do that requires them to be small. There's actually a lot more to do with their ability to exist. So this single cell paramecium here is a very small object. For materials on the outside to get in and move effectively to these organelles, they rely on a process called diffusion. And for materials to get out, wastes and things, they also rely on diffusion. So the higher the surface area to the volume ratio, the more effective this is. And we're going to have a look at that with an experiment soon. So this is the idea of surface area to volume ratio. So our nucleus in each of these drawings is the same size. They don't look it, but they are. In this really big cell, this nucleus would be waiting a long time for material to diffuse in and tell it what it wants it to do. Not as long in this cell, and quite quick in this cell. And this is one of the reasons that cells tend to be quite small. The ability for things to move in, create the change they need to create. So we're looking at chemicals moving, and chemical signal changes all the time. They need to be able to reach the organelle they want reasonably quickly. So that one's probably maybe too small. You could probably get away with being a bit bigger than that as a cell. This is obviously far too big. The spaces between organelles, distance travelled is probably too great. So this tends to limit how big a cell can grow. We also see this in organs. So we'll talk about this later in this term, and you'll look at it much more next year. However, in this diagram here, and someone has drawn over it, but anyway, this is the interior of your small intestine. And we have villi, which are these projections that run up and down inside, all along both sides of your small intestine. But on their surface, there are microvilli. You can see them made out there in that diagram. It's all really jagged. So that creates a whole lot more surface area. And of course, your small intestine uses diffusion for things to enter the or cross the wall of the cell membranes of the small intestine, of the villi, and then into the bloodstream. So you try and get all the nutrients you can out of your food. So by having all these projections and these micro projections, you create more surface area for diffusion to occur across, and you slow things up. So there's a better chance of getting nutrition out of your food than simply it flowing straight through. If it's a smooth-celled tube, then most of the food we eat would pass through without getting much from it. We find this throughout our bodies, in our lungs, and all sorts of places where there is attempts to increase the surface area so the functioning of that organ or that system can work better. And we see it with cells. So it's a really big idea we'll come across a lot.